Hi everyone, and welcome to Backer Breaks It Down. This episode, we look at the law of sines and using the law of sines to solve oblique triangles. So let me remind you of the law of sines. The law of sines states that the ratio of the sine of an angle to the length of its opposite side is the same for all three angles in any triangle. This relationship can be expressed using these three ratios here. Remember, opposite angle A is side A, opposite angle B is side B, and opposite angle C is side C. The law of sines can be used to find missing sides and missing angles in an oblique triangle. Remember, to find a missing angle measure, you do need to use an inverse trig function, which requires you using the second button on your calculator. Speaking of calculators, check your mode right now. Make sure it's in degree mode. So in this triangle here, we want to use the law of sines to solve it. So that means I want to find the measures of angles A and B and the length of side BC. So I'm going to start by labeling my sides A, B, and C. So remember, opposite angle A is side A, opposite angle B is side B, and opposite angle C is side C. So where do we even begin? Well, what do we know? Because that will tell us where we can begin. Well, we know that side B is 23 degrees, or units, I should say. We know that side C is 27, and we know that angle C is 36. So basically, we see that this is where we can start. We can start with these two ratios here, right? So I can create a proportion for B and C, and I can use it to find missing angle B. So that's where I begin. So I have sine of angle B, which is unknown, over 23 is equal to sine of angle C, which is 36 degrees. So sine of 36 degrees divided by 27. Okay, so here is where I start for this problem. Okay, and so I've naturally have already done this work. So let's just see where we are now. So after writing that initial equation, we can cross multiply. So 27 sine of angle B and 23 sine of 36. I need to get sine of angle B by itself, so I divide. So I end up with sine of angle B is equal to 23 times sine of 36 divided by 27. I calculated that and got the decimal 0.5007. Then it's like, wait a second, I don't know the angle measure. So I have to calculate the inverse sine of that decimal to get my angle. So I've just discovered that angle B is 30 degrees. So realize now that I know the measure of angle B, I can find the measure of angle A by doing some simple subtraction. And that's what I'm showing here. So I'm saying the measure of angle A is equal to 180 minus 36 and minus 30. The 36 was the measure of angle C, and 30 is the measure of angle B. So I did the math and I got that angle A was 114 degrees. So now all that I don't know is the length of side A or side BC. Okay. I can still use what I started with initially. So initially, remember, I knew the C ratio, but so now I need to use that, and I need to use the A ratio to find side A. And so that's what I'm doing here in step 3. So the sine of 36 over 27, that's angle C and side C. The sine of 114, well, that's angle A. And then, of course, I have side A. From there, I need to cross multiply. So that's what I did. I went A times sine of 36 and 27 times sine of 114. Then I did that division. and I calculated 27 sine of 114 divided by sine of 36. And that's how I got 41.96 for the measure of side BC. So still, the right place to start with these problems is what do I know? You saw me kind of use my law of sines formula as a checklist. So I'm oh, I know that B is 23, I know C, I know angle C. And so that kind of gave me some guidance onto where to even begin. And then from there, you're just finding those missing measurements in your triangle until there's no more measurements to find. And so that's how you can use law of sines to solve an oblique triangle. Okay. And that's how Thacker breaks it down.